Imagine falling towards something so powerful that not even light can escape. No spaceship could turn around. No signal could reach Earth. And according to Einstein's theory of relativity, time itself would begin behaving strangely. This isn't science fiction. It's a black hole. But what would actually happen if you fell into one? A black hole isn't simply a giant hole floating through space. It is an enormous amount of mass compressed into an incredibly small region. Imagine taking something as massive as the Sun and squeezing it into a sphere only a few kilometers across. The gravity becomes so extreme that space and time are dramatically distorted. At the center is what physicists call a singularity, a region where our current understanding of physics breaks down. Surrounding it is the event horizon. Think of the event horizon as the ultimate point of no return. Once something crosses it, escaping would require moving faster than light. And according to everything we currently understand about physics, nothing can do that. Now imagine you're approaching a black hole. At first, you might not notice anything unusual. But as you get closer, the black hole's gravity becomes extreme. The light coming from behind the black hole would become distorted, creating bizarre rings and arcs around it. And something even stranger would happen. To a distant observer watching you fall, you would appear to slow down as you approach the event horizon. Your light would become increasingly red and faint. Eventually, you would seem to freeze near the edge and disappear. But from your own perspective, you wouldn't feel yourself stopping. You would continue falling. And that's where things become truly terrifying. If the black hole were relatively small, the difference in gravity between your head and your feet could become enormous. Your feet would experience a much stronger gravitational pull than your head. Your body would be stretched vertically and compressed horizontally. Physicists have a rather disturbing name for this. You would be stretched into an extremely long, thin shape as the black hole's tidal forces became stronger. Eventually, your body, and eventually even individual molecules, would be torn apart. But here's the fascinating part. If you approached a supermassive black hole, the situation could be very different. Because its event horizon is much larger, the gravitational difference across your body at the horizon could actually be relatively small. You could cross the event horizon without immediately noticing anything dramatic. The real danger would come later, deeper inside. And this is where science reaches its limits. Once you're inside the event horizon, every possible future path leads deeper into the black hole. You cannot turn around. You cannot send a message back. And eventually, according to classical general relativity, you would reach the singularity. But there's a problem. Einstein's theory predicts conditions where density and spacetime curvature become effectively infinite. Physicists don't believe this is the final answer. They expect that a future theory of quantum gravity may explain what really happens. Right now, we simply don't know. Black holes may sound like monsters hiding in the darkness. But they're actually one of the most fascinating predictions of modern physics. They show us that space isn't simply an empty stage where the universe happens. Space itself can bend. Time can change. And gravity can become so powerful that even light cannot escape. The universe still has places where our best theories stop giving us answers. And perhaps the strangest thing about black holes is this. They're not just hiding something from us. They're showing us how much we still don't understand. If you want more mind-bending astronomy and space science, subscribe. Because the universe is far stranger than science fiction.